So we estimated the values of the slopes of the tangent lines at x equals 1, 2, or 3. But now we're going to zero in on the slope of the tangent line at x equals 2. We want to actually see if we can calculate what that slope is. So again, I've pre-graphed the curve from x equals 0 to x equals 3. And so we are ultimately interested in the slope of the tangent line at that location. Now, to use our slope formula, we need 2 points. We need a x1, y1, an x1, f of x1, and an x2, y2, or an x2, f of x2. So we're going to start off with our 2 points being the ones that are at x equals 2 and at x equals 3. So we're going to start off with these 2 points. So the coordinate here is 3, 9. The coordinate here is at 2, 4. So we want to find the slope of the line using those 2 points. So that's what we have here, 2f of 2 and 3f of 3, or 2, 4 and 3, 9. And so if we find that slope, we're going to have 9 minus 4 on the top over 3 minus 2 on the bottom. So we get 9 minus 4 is 5 over 3 minus 2 is 1. So we get a slope of 5. Now, hopefully we look at that and say, well, we know that's not the slope of the tangent line because the line that goes through those 2 points isn't just touching our curve at one location, it's cutting through it, it's intersecting. It's going through both those, and so it's slicing through the graph rather than just bumping up against it. I'm going to remove that just so it doesn't clutter our diagram. So that's an estimate of the tangent line, but hopefully we can see that that line is a little bit too steep compared to what our actual answer is. Because now what we're going to do is we're going to slide this point downwards here. So maybe I'll change colors here. I'm going to move this point. So now we're no longer at x equals 2 and x equals 3 as our 2 points. But now we're going to say we're at x equals 2. We're going to bring that second point a little bit closer at x equals 2.5. So if we square 2.5, we get a y-coordinate of 6.25. So if I'm over 2.5, I'm up. It's like roughly here. It's going to be my point. So we've got 2.5, 6.25 is our second point now. So I'm still going to be using 2, 4 as the point 2 or point 1, but now I'm using this as my point 2. So if we do our slope calculation, we've got 6.25 minus 4 over 2.5 minus 2. So just the difference between the outputs divided by the difference between the inputs. So we're going to get 2.25 divided by 0.5. And so this time, if we push buttons on our calculator, we're going to get an answer of 4.5. So now our slope has gotten a little bit flatter. We're not at 5 anymore as our estimate. We're at 4.5. But again, this is still just an estimate. We have not actually calculated the slope of the tangent line because we still have our line is passing through 2 points on the graph rather than just bumping up against it at just one. It's not a true tangent line yet. But this estimate's a little bit better because we've moved these points a little bit closer together. So let's get these points really close together. Now, let's say we're not at x equals 2 and 3 like we were on the first estimate, or x equals 2 and 2.5 as we were on the second estimate, but now we're going to be at x equals 2 and x equals 2.01. We're going to be as close as we can possibly be. So the coordinates of this second point now are going to be, so for the green point, that's just barely to the right of our initial point, it's going to be 2.01, and then if we square that, we get 4.0401 as the coordinate to the second point. And so if we plug those values into our slope formula, we've got 4.0401 minus 4 in the numerator. We've got 2.01 minus 2 in the denominator. And so if we calculate that, so we get 0.0401 in the top, we get 0.01 on the bottom. And so if we divide that, we get an answer of 4.01 as our estimated slope of the tangent line. I'm hoping at this point we can see where this is headed. So if I asked you to pin down what exactly is the slope of the tangent line, based on the trend that we see, we went from 5 when the points were 1 unit apart to 4.5 when the points were half a unit apart to 4.01 when the points were just 1/100th of a unit apart. I'm guessing that we can come to the conclusion that the slope of the tangent line is actually 4. Now, the problem that we have here is if we actually try to calculate that using the information that we have, if we were to take these 2 points and now merge them together so that we had just 1 point, well, the problem that we would have is we would have a slope equation that would be 4 minus 4 over 2 minus 2. If I use the same point for both the input-output of x1 and the input-output of x2, we're going to end up with the same y-coordinate, 4 minus 4, over the same x-coordinate, 2 minus 2, which means we're going to get 0 equals 0. Now that does not mean that we have an undefined value. We clearly know that there is a tangent line and that that tangent line has some sort of slope. We've kind of deduced that it's going to be 4, but as soon as we try to calculate it, we get this 0 over 0. Now if we recall, when we were looking at those rational functions and we had the circumstances where we had a removable discontinuity, we would end up with not a number over 0, we'd end up with 0 over 0. That was the indication that there was a removable discontinuity, which we then could try to calculate what the output of the function is, what the limit was as x approached that certain value. And that's really what we're looking at here, is we're looking at a limit question. We're asking what is the limit of this function? What is the limit of this tangent slope as we merge these 2 points together? So as we get that gap smaller and smaller, we get a better and better estimate as to what that slope is going to be. But the moment we merge those points into one, we run into this problem that we see over here. So we're going to figure out how we deal with this issue in our next day's notes. But the last thing that I want you to do is to go through this same process as you see on the bottom of the worksheet for the other points in question. So I want you to see if you can figure out what is the slope of the tangent line at x equals 1 and at x equals 3. See if you can come up with the estimate, because we can't calculate it directly, of what you think the slope of the tangent line at each of those locations is using this same process. And then we'll pick up with this in our next lesson.